SQA National 5 Application of Maths 2018, Paper 2, Question 1. Jack bought a car 3 years ago costing £1,400. It decreased in value by 13% each year. Calculate the current value of the car to two significant figures. So it's depreciation, it decreased by 13%, so they're 100 minus 13%, 100 minus 13. That gives me 87%, which is 0.87, as you divide by 100. So now your sum is just 1,400 times 0.87 to the power of 3, because it's 3 years. And that's a calculator job. That gives me 921.904. So rounding that to two significant figures, so that means we're cutting it here. That's £920, and we're done there. Part B. Jack sells his car for £950. Calculate the loss as a percentage of the original price. So I need to know how much he lost, first of all. So it's 1,400 he bought it for, minus 950. Well, that's £450 loss. So as a percentage of the original price, well, that's the same as a fraction. So that's 450 divided by the original price, which is 1,400, times 100, because I want it as a percent. 450 divided by 1,400 times 100 is 32.14285. 32.142%. No need to round, so we're done there. SQA National 5 Application of Maths 2018, Paper 2, Question 2. The number of podcasts Omar downloaded each month is shown in the table below. For this data, we have to do the median, lower quartile, upper quartile, and then we have to do a box plot for this. So this is quartiles and box plots. So we need the data in order. So I've already written the data in order from smallest to biggest. Just take your time doing that, otherwise you can make a mistake quite easily. So we want the median, so that's the one in the middle when you put them in order. So let's find how many there are. There are 1, 2, 3, 4, 5, 6. There's 12 of them. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You can see there's 2 in the middle. So it's in between those two, 19 and 19. So it is 19. But there's where my median actually is. Median, we can write 19. So now the lower and upper quartile is just the lower half and the upper half, then one in the middle of each. So I've got 1, 2, 3, 1, 2, 3. So it's in the middle of these two. So I can take a note of that. In the middle of 10 and 12 is clearly 11. So that's the lower quartile. In the upper quartile, 1, 2, 3, 1, 2, 3. I want in the middle of 22 and 26. Well, there's 4 between the numbers, so it must be 22, 23, 24. One other way to do that, if the numbers are quite big apart, is add them up and divide by 2 and take the average. But we get 11, 19, and 24. So let's just take a note of that as our answers. 19, 11, 24. And now we have to draw a box plot. So we've got a diagram here. So our box plot, the first thing we start off with is the smallest number. So that's 5. Being nice and neat, making sure you use a ruler. And then we've got our highest number, which is 34. So 35, 34 is there. Just checking that these go up in ones. Now we go to our lower quartile, which we know is 11. So there's 11 there. So just start drawing a box there. And the upper quartile we know is 24, which is here. So we get our upper and lower quartile in and we draw a box around that. So there's the first line and there's the second line. Notice I'm not using a ruler, but that's because my iPad can do that. You use a ruler. And then we put our median where it goes. Our median is 19. So just below 20, there's my median. And we can just connect that up here. And we can connect that up there. And there's a completed box plot. So we can just take a note of all the things in the box plot so we know what we've got. That's our lowest. That's our highest. And then we've got our lower quartile, our median, and our upper quartile at the end. So we're showing that we know exactly what all these numbers are, and we're done there. SQA National 5 Application of Maths 2018, Paper 2, Question 3. Ross has changed his internet package, and we've got a table below showing the packages he's considering. So this is reading information from a table. and it says he needs 52 megabytes per second, 50 gigabytes of usage at least, and a 12-month contract. Which package will we choose with the lowest overall annual price? So he needs to choose a package that gives him everything he wants. So let's check the ones he can't have first of all. He needs 52 megabytes per second. So C's out because that's 38. So that's C gone. He needs 50 gigabytes of data or usage. So A is out. And unlimited is fine. 50 gigabytes fine. He needs a 12-month contract. Well, that means E is out because that's only 24 months. So that only leaves us with B and D. So we'll work out the cost of them separately and see what one's the cheapest. So let's look at B to start with. It costs £8.95 a month and £20.99 a month with an initial fee of £59.99. So I need to add these two together and times by 12 and then add on the initial fee. So that's £8.95 plus £20.99. That gets times by 12 and then we add on the initial fee of £59.99. So £29.94 times 12 is £359.28 plus £59.99 gives us a total of £419.27. And now we'll do the same for D. So D is £7.99 a month and £18.99 a month. So take a note of that. £7.99 plus £18.99. That's still 12 months. But then the initial fee on this one is £109.99. So we need to add that on. £7.99 plus £18.99 is £26.98. You can take a note of that if you want, or since I've used brackets, I can just press times 12. That gives me £323.76. And then add on the initial fee of £109.99. Then we get a grand total of £433.75. So which one will he choose? He will choose B, as 419.27 is less than 433.75. And we're done there.
SQA National 5 Applications in Maths 2018 Paper 2 Question 4. Nicola has joined the gym. The pie chart shows the proportion of time that Nicola will spend on each type of workout exercise. So we've got warm-up, cardio, resistance, cool-down. She spent 1 hour 45 minutes in the gym. So that's the total of the pie chart. How long in minutes did she spend on resistance training? So I need to identify the bit that's resistance training. So it goes warm-up, cardiovascular is the light grey, resistance is the dark grey. So it's 144 degrees. So it's 144 out of 360 is the fraction because it's 360 degrees in a circle. So that's what fraction she spent. And it's times, I need to times by the time. But the time is 1 hour 45. So I want it all in minutes. So that's 105. So let's get my calculator for that then. 144 divided by 360 times 105 is 42 minutes. And we're done there. Nicola spent 21 minutes exercising on a treadmill. Her average speed was 6.6 kilometers per hour. Calculate the distance she ran on the treadmill. So distance, speed and time question. So some people like this, some people don't, but I'm going to do it anyway for those that do. You can imagine a triangle like this, distance, speed times time. And I want to work out the distance. So if I imagine covering that one up, I do speed times time. If I wanted to work out the speed, I would imagine covering that up, and it would say distance divided by time. And similarly, if I covered up the time, I would then know that time is equal to distance divided by speed. So it's a nice trick that helps. So I now know that distance equals speed times time. So let's write down my speed, 6.6 kilometers per hour. And let's look at our time, 21 minutes. Now that's the problem. Hours and minutes are not the same. They need to be the same before you do any sums. So you can either change your speed into kilometers per minute, or much easier, to be honest with you, change your time into hours. So to change your time into hours, 21 divided by, well, it's 60 minutes an hour, so divide by 60. 0.35 hours. If you don't do that step, you're going to lose a mark. So now I just do 0.35 is the one number, and it's times by 6.6. 6.6 times 0.35 is 2.31. 2.31 in the units, well, it was kilometres per hour, so it's kilometres for distance, and we're done there. SQA National 5 Application Maths 18, Paper 2, Question 5. 3 tonnes of sheep food will feed 350 sheep for 18 days. The number of sheep increases by 100. How long will the same food now last? So this is called reverse proportion. So we know that 350 sheep will be fed for 18 days. I want to work out how much 450 sheep will be fed for. So why is this inverse proportion? Well, it's either work done or it's getting fed. If you think about these sheep, if I was to say, well, how long does the food last one sheep? Clearly it lasts a lot longer. So you're not going to do 18 divided by 350 because that means that one sheep, it would only last like hours. That makes no sense. So for one sheep, since this is inverse proportion, it's 350 times 18, which is 6300 days, which means for 450 sheep, I now divide by 450, 6300 divided by 450, 14 days, which makes sense. More sheep, less days. So if you get an answer like more sheep and it lasts more days, that doesn't make sense. That means the sheep are eating less. SQA National 5 Application Maths 18, Paper 2, Question 5, Part B. The storage container for the sheep food is in the shape of a cylinder with dimensions as shown below. We have to calculate the volume of the storage container. The volume, this is a cylinder, so the volume of a cylinder is pi r squared, area of the base, which is a circle, times the height. So we need to know the radius. Well, all the way across is called the diameter. The radius is half of that, so I can immediately work out the radius and always do that first. Don't just jump in by dividing by 2. 3.8 divided by 2, which is 1.9. You either have to work out the radius usually in these questions, or maybe a height because there'll be an extra bit or something. But it's just the radius in this case. So now I can just substitute in. That's pi times 1.9 squared times 9.7. Double checking the units are the same, and they are. Calculator. Pi times 1.9 squared times 9.7, 110.009. I always put ... to show I've not rounded. And then the units are meters, but it's volume cubed. SQA National 5 Application Maths 18, Paper 2, Question 6. Ali, Kate and Jim are paid to deliver leaflets advertising on a restaurant. They shared the money they were paid in the ratio, so it's a ratio question, 357. Jim received 154. How much did the restaurant pay in total? So let's just write this out. The ratio is 3, 5 and 7. The order is Ali, Kate and Jim. And it tells me that Jim's paid 154. So let me put 154 under Jim. So if 154 is paid to Jim and his bit's worth 7 pieces, I could work out one piece, then work times by 5 and 3 to work out the other bits, or times by the total of the ratio to work out the total bits. So I do 154 divided by 7. That gives me 22. And now adding the ratios up because I want the total. 3 plus 5 plus 7 is 15. So the restaurant will pay in total 15 lots of 22. 15 times 22, £330, and we're done there. SQA National 5 Application of Maths 2018, Paper 2, Question 7. Sam drives from Paris to Zurich and he knows his car will cover 47 miles per gallon of fuel, and the fuel tank holds 50 litres and it's 650 kilometres from Paris to Zurich. Will we be able to complete it on a tank of fuel? So it gives us a few conversions, so we're doing some conversions here. 1 mile is 1.609 kilometres. and a gallon is 4.54 litres. So we're just going to try each bullet point in turn and see if we can get anywhere with this. His car will cover 47 miles per gallon of fuel. Great. 47 miles, but I've got it in kilometres. So bullet point 1, it'll do 47. 1 mile is 1.609 kilometres, so times 1.609. And that'll tell me how many kilometres he does in a gallon. He does 75.623. Now I'm not going to round because there's going to be a lot of sums. 75.623 kilometres per gallon. Next bullet point says the fuel tank holds 50 litres of fuel when it is full. But I don't know much about that. I know gallons. I know I'm getting 75.623 kilometres per gallon. So I'm going to turn that into gallons. So I'm starting off with 50 litres. So I've done bullet point 1, bullet point 2. I'm starting off with 50 litres. I want to go backwards to gallons, so I'm going to divide by 4.545. So that's 11.0011 gallons. It now says it's 650 kilometres from Paris to Zurich, where I know I get 75.623 kilometres for every gallon, and that's how many gallons I've got. So I just times them together to see how far I get. So for bullet point 3, I'm doing 75.623 times 11.0011. That gives me 831.94 kilometres. So the answer is yes, since 831.94 kilometres is less than 650. Now there's other ways to tackle this question. SQA National 5 Application of Maths 2018, Paper 2, Question 8. Scott devises to buy a new track bike. Scott needs to buy a frame, handlebar, pair of pedals, saddle, 2 wheels and 2 tyres. Different retailers' offers are shown, price in pounds on the table. So Scott can buy parts from different retailers. A bike frame costs 2640.95. Calculate a minimum cost of frame and parts. So this is a question where basically we are just taking information from a table and then just adding up our answers. So let's have a look at what we've got here. We are looking for a frame and parts. So let's look at the frame first. So the bike frame costs 2640.95. That's just a fixed price. So I can just write that down. And then we want parts. So we just want one of each, I think. Handlebar, pedals, saddle, wheels and tyres. But make sure we get 2 wheels and 2 tyres. So handlebar, the cheapest place to go is going to be in this column. And we're looking for the smallest number, which is 55.49. So I'm going to add 55.49. And then we want the pedals. Well, that's 33. 33 is the cheapest. And then we want wheels, but we want 2 of them. So the cheapest place to buy wheels is 44.49. So 2 44.49. So I'll just write 44.49 twice for the sake of it, because it'll be, I just want to add some. Plus 1 saddle at 41.66. Plus 2 tyres at 49.99. So 2 49.99s. So just being careful that when I add up all these numbers in my calculator, I just don't mistype anything. 2640.95 plus £55.49 plus £33.33 plus 44.49, another 44.49 plus 41.66 plus 49.99 plus another £49.99. We get 2960.39. So the minimum cost is 2960.39. And we're done there. Question 8b. Scott cannot afford to pay for the bike all at once. The cash price for the bike from EP Bikes is 299,100. Let's just take a little note of that. Choose to buy a complete bike from EP Bikes as they are only offering a finance package. The finance package consists of a deposit of 15% of the cash price and 36 payments of $76.50. Calculate how much more this finance package will cost compared to the minimum total cost. So the cash price is $2,991. So this is a payment plan and we just need to work out the due bullet points. So let's start off with 15% of 2,991.00. So calculator for this. So to work out 15%, 15 divided by 100 or 0.15, I'll do 15 divided by 100, that's 15%, times 2,991. That gives me 448.65. So that's the deposit. Now it says 36 payments of £76.50. So 36 times £76.50. 2,754. So we need to add these together to get our total price. $2,754 plus 448.65 is 3,202.65. And now to answer the question, which says calculate how much more this finance package costs compared to the minimum, we need to do 3,202.65 minus the minimum, which we got back here of 2,960.39. Always doing this in our calculator if it's a calculator paper, not giving ourselves a headache. And we get a total price of 242.26 is the difference. So we'll just take a note of that. 242.26. And there's our final answer. C. Scott trains at the velodrome on his new bike. He records his top speed in kilometers per hour for each lap. 6 of the speeds are shown, and we'll have to calculate the mean and standard deviation and then make 2 valid comments. So quite a standard thing. Check the start of the exam paper for the mean, well, the standard deviation formula. The mean you should already know. And remember, there are 2. I'm just going to use one of them. So the standard deviation formula I like to use from the start of the exam paper is the square root of the sum of x minus x bar squared over n minus 1. And if you use that formula, you can remember there's a table that you can draw and then just work it out. So let's draw a table. So you've got x, that's all your numbers. X minus x bar, now x bar is the mean, so let's just take away the mean in the middle. And then x minus x bar squared means whatever answers you've got here, you're just squaring them here, and then you're going to get a total. Now that total is the whole top number. N is how many numbers you've got, so I take away 1 from that and divide by that and square root the answer. So let's start that. 61.2, 58.3, so I've now got all my numbers on my table, so I can work out the mean, which is x bar. So working out the mean, which is x bar, you just get your calculator, add up all the numbers, take a note of that total, and we're going to divide by how many numbers there are, which are 6. $59.6 is our mean. And the units were kilometres per hour. You won't usually lose marks for not putting units in, but I'll put it in for the sake of completeness. So that's been done part 1. I've done the mean. Now I'm going to do the standard deviation. So we take away 59.6 from each of the numbers on the left. 61.2. 1.6 is our first one. Don't worry if you get negative answers, that's perfectly normal. $60.4 minus 59.6. And the last one. So now we've got all these answers. Now when you square a negative number, you get a positive answer. So in your calculator, to save you making any mistakes, just take the number and square it, okay? Forget about the negative. So 1.6 squared, 2.56. 1.3 squared is 1.69. 0.5 squared is 0.25. 0.8 squared is 0.64. 0.8 squared is still 0.64. And 0.2 squared is 0.04. Usually you get a mark at this point for that bit of the table correct. Then we just add it all up. $5.82. Get rid of that for a minute. So that's our key number. Because now to work out our standard deviation, it's just the square root of 5.82, because that's what we just worked out, divided by 1, 2, 3, 4, 5, 6 numbers, so 5. Now here's a mistake that I see people make all the time. The square root of 5.82 then divide by 5. You need to make sure that you're square rooting the answer to 5.82 divided by 5. Now, if you're doing it in a calculator, that's what I'm doing. I put a square root. I make sure I open a bracket, so I do my divide inside the bracket. 5.82 divided by 5. If you don't open that bracket, the calculator will do the square root of 5.82 first. So be very careful. 1.078. And it goes on for a bit. So I'll just round that to 1.08. Again, kilometers per hour if you want for units. And we're done there. Part C of this question says, Part D, says, Scott had a mean top speed on his old bike of 57.3 kilometers an hour and a standard deviation of 1.21 kilometers per hour. Make two valid comments comparing the top speed on the two different bikes. So this is his old bike, 57. Let's look at the mean first. We've got 57.3 and our new mean was 59.6. So if I put old mean, 57.3, new mean, just so I can compare them next to each other, 59.6. And then old standard deviation against new standard deviation. The old one was 1.21 and the new one is 1.08. Okay, so we're going to compare the mean and the standard deviation. Let's compare the mean first. So our mean statement, don't have to write that, I'm just writing it for the sake of this video so you can see it very clearly. The word you want is average every single time. So for comparing the mean, you say on average. So always start with that statement, on average. And then all you do is look at the numbers. So I'm just going to go for saying one is bigger than the other. So this one is bigger than that one. So on average, now we need to do it in context. This was like a top speed of his bike. So on average, the top speed of his new bike is bigger than the top speed of his old bike. So notice I'm saying on average, but then I'm talking about what it is in context, the top speed. Okay, do not say on average the mean is bigger. That would be wrong. Don't mention the mean again. So now you just say, you can say because you don't usually have to show, but just to be on the safe side, because 59.6 is bigger than 57.3. So there's a mark for the mean statement. Now I'll do the standard deviation statement. So for the standard deviation statement, I always talk about, you can either talk about consistency or variability. Now I prefer variability because that means bigger number means bigger variability, whereas with consistency, bigger number means less consistent. So you're better off with variability, in my personal opinion. So I'm going to look at the two numbers. The old bike's top speed standard deviation was 1.21. That's bigger than 1.08. So not on average, but looking at the top speeds of his old bike was, and here's the keywords coming, more varied than the top speed of his new bike. Since I always write this, 1.21 is bigger than 1.08. And we're done there. SQA National 5 Applications of Maths, 2018, Paper 2, Question 9. A factory produces cans of tin beans. The table below shows a list of tasks and time to complete them. Complete the diagram to show the tasks and times in the box. So there's my tasks and times. Let me just make that a bit smaller so we can see it all. So this is what you call a precedence table. So C's already been done for us because it's on the chart and it says preceding task none is C. I look for preceding task none again, and that's F, so that's the other one at the start. So F takes 900, so I can just fill that in. I then look to see what comes after C. So after C in this column is A. A takes 500. Let's tick it off as I go. After F, well, F in this column is here, and that gives me E, so I can tick that. E takes 2. And then after A, there's A here, it's H, and that takes 2 as well. And then I'm looking for one after E and H. So there's E and H there, that's B, and that takes 3. So B is 3. After B is I, and that takes 300. After I is D, and that takes 5. And after D is G, and that takes 5 as well. So I've filled in my chart. Part B, the factory manager thinks the whole process can be completed in less than 25 minutes. Based on the times given, is the factory manager correct? Well, let's look at our chart. We need to identify the path that gives us the longest time. So if you look at this one here, that adds up to 5, 6, 7, 8, 802. But I can't move on to B until I've finished this, which takes 902. So the path I need to write is this plus this, plus this, this, and this. So that's 900 plus 2 plus 3 plus 300 plus 5 plus 5. Use a calculator anytime you want, but that's 9, 10, 11, 12, 12, 10, 12, 15. 12, 15, and that's in seconds. So I need to change that to minutes. So it changes seconds to minutes, 60 seconds in a minute. So I'll do 12, 15 divided by 60. 12, 15 divided by 60 is 20.25 minutes, or 20 minutes, and 0.25 is a quarter of a minute, which is 15 seconds. So, can be completed in less than 25 minutes. Is he right? Yes, since 20 min, 15 seconds is less than 25 min. And we're done there. Question 9 continued for 2018 paper 2. The tins are packed into boxes. Each box has a dimension of 60 by 40 by 15 as shown, and we have to store it this way up. And they're going to be put into a shipping container, and the internal dimensions are 240 by 1250 by 260. Just first thing to check with box packing, are the units the same? If not, you need to make them the same, 100 centimetres in a metre, 10 millimetres in a centimetre, and so on. But if they are the same, so we're fine. Calculate the maximum number of boxes that fit into the container. So there's a process you can do this, and this is my process. You might have seen this before, hopefully you have. I draw a little table. And what I do is, I'm just going to call that my height. I'm calling that my breadth. You can call it anything you want, and my length, or my width if you want, actually. We'll call it width, it's more modern. Height, length, and width. So let me write down, and that's the same, height, width, and length. So let me write down height, width, and length, and one of them is not allowed to change because you have to store it this way up away the height. So the height is my fixed position. So I'm just going to put a little mark there to show that. And what you always do is you take one of the numbers and just divide it by the other number. So I'm going to do height divided by height first because that makes sense. So option 1, I'm going to do 260 divided by the height of 15. Do the sums at the end. Then I'm going to do width, so 1250 divided by the other width of 40. And I've got 240 divided by the other length of 60. That'll tell me how many I can fit in along the way, down the way, and up the way, and then I just times them all together to see how many I've got in total. So that would be option 1. But I've also got another option. I could take this box and turn it around so that this length is going against this width, and this width is going against this length. Now, you don't need to think too much about that, but that's what would be happening. What I can't do is turn the box upside down and make the height go against anything else. So the height stays the same, so I keep it the same, sum. The length, the width of the big box is still the width of the big box, and the length is still the length, so they're fixed. But what you can change is you can just swap these two numbers, 60 and 40, and there's option 2. And then if I could swap any more, I would do an option 3, but I can't swap any more because this whole thing's meant to be fixed. This is always going to be the same sum, so the only two I can swap are these two, so that's me done. Now, when you're doing your sums, you do round because it is a real thing that's happening. So when I do 260 divided by 15, if I get an answer like 0.1, I just round down because I can't put an extra little bit on. This is the one time you round down. So 260 divided by 15, I write 17.3, which is about 17. 1250 divided by 40 is 31.25, which is about 31. And 240 divided by 60 is exactly 4. So the three numbers I've got are 17, 31 and 4. I times them together to get how many I can fit in. 17 times 31 times 4. That is 2108. Keep a note of that. Move to the other side. We already know 260 divided by 15 is 17.3, which is about 17. 1250 divided by 60 is 20.8, which is about 20, not 21, because you can't fit any extra in, so you have to go for the shorter, 20. 240 divided by 40 is 6, so my three numbers for this side are 17 times 20 times 6, which is 2040. So now to answer the question, what's the maximum number of boxes you can fit in the container? You can fit max of 2108, the bigger number, and we're done there. 2018 Paper 2 Question 9 continues Part D. It takes 277 hours to sail from the UK to Canada, so this is a time zone question. The local time in Canada is 5 hours behind the local time in the UK. The UK ship leaves the UK. The ship leaves the UK at 2200 on the 3rd of June. Calculate the date and local time the ship will arrive in Canada. So let's take a note of everything I've got. Let's start off with the UK because we're going to the UK. So we're on UK. We're leaving at the 3rd of June, and that is 2200. And I'm going to go to Canada, so I want Canada time. So on Canada time, let's have a look. It says Canada is 5 hours behind, less than the UK. So I do 2200 minus 5, 22, 21, 20, 19, 18, 17. Go on, leaving at 1700 Canadian time on the 3rd of June. And if I deal with that straight away, I don't need to think about it at the end. And I'll just do my hours, 277 hours. So I've got 277 hours to deal with, and that's like a number of days. How many hours are a day? 24. So I'm going to divide that by 24. Now that's 11 days, but I've got this point bit to deal with. Now to deal with that, I times the decimal bit by 24 again, and that will tell me how many hours are extra. Don't round it, because if you round it, you've not done something exact. So to deal with that, I keep it in my calculator, press equals, make sure it's done, and just press minus 11, the whole number part, and that gives me my decimal, so press equals. And then I just times that by 24, because there's 24 hours in a day, and that'll give me 13 hours. So I'm taking full advantage of my calculator here, because it is a calculator question. The other way you could have done it is just counted in 24s to get 11 and see what the remainder was, and that would be the number of hours. Okay, so I know it's 11 days. So I'm on the 3rd of June. So if I add 11 days, 3rd of June becomes 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14th of June. And then add 13 hours. So 5 o'clock becomes 17, 18, 19, 20, 21, 22, 23, 0, 1, 2, 3, 4, 5, 6. But I've went past a day, so I now need to add a day. So we're on the 15th of June at 0600 hours. And we're done there. Screen Answer 5 Application Maths for 18, Paper 2, Question 10. Fiona is a vet, she has started a new job. Her salary is £42,000. National Insurance is calculating the patient's salary before deductions such as pension. Calculate Fiona's national insurance. So we've got this table. Let's take a note that we've got 42,000 as the salary. And then this table tells us the national insurance rates. It says up to this amount is 0. So for the first 8164, I pay £0 because it's 0%. And then says between these two numbers, you pay 12%. Now that's only if you actually earn up £45,032. But she earns 42,000, she never reaches that, so you just take her wage, 42,000, minus the lower number. If she earned more than this number, I would work out all of that, and then I would take her wage minus this number, but she doesn't earn as much as that, so I can ignore that one completely. So the sum I'm going to do is 42,000 minus 8164, get the answer, and then I'm going to work out 12%. So you can times by 12 and divide by 100, or you can use a sneaky way, 0.12, and that's much simpler. Notice I'm using brackets, full potential, so I can just do it in one go, or you can take your time and do it in small stages. Minus 8164, so I've done my brackets, times that by 12 and divide by 100, or 0.12, and that gives me 40, 60, 32. And that's my answer. I'll just put it here just for the sake of being able to use it in a minute. Now, if it was more than one answer, like one here, I would add both answers together. Okay, Fiona's annual income tax payment is 5427.96, and she pays 3360 to her pension, and she's paid in 12 equal monthly payments. What is her monthly net pay? Net is after you take everything off the gross pay. So our gross pay is 42,000. So to work out her net pay, all you need to do is do 42,000, her actual pay, minus her national insurance, so 4060.32, minus her income tax, 5427.96, minus her pension, 3360. So do that first, and that will tell me her yearly wage after everything's off. 42,000, 4060.32, 5427.96, and 3360. That gives me 29151.72. and that's per year. So for a month, I just do 29151.72 divided by 12. So I've already got that in the calculator, divided by 12. That's a total of £2,429, pound sign, 2429.31. And we're done there. Okay, question 10b. Fiona plans to rent accommodation. She needs to work out how much she can afford to spend on rent, electricity and council tax. The table shows her monthly outgoings. So here is the outgoings all here, and there's a total box at the bottom. Calculate how much she will have available per month for rent, electricity and council tax. So this is all our outgoings except the rent, electricity and council tax. So I need to add all these up. So let's just get a calculator and make a running total. 395 plus 28 plus 12 plus 380 plus 130, 64, 55, 250, 200, 200 is 1714. 1714 is how much she spends out, but how much did she earn? We worked that out before, is 2429.31. So the sum I need to do is 2429.31 from the amount she earns minus 1714. Not doing that without a calculator. 2429.31 minus 1714 leaves £715.31 for all the other stuff she needs to spend, electricity, rent and council tax. Okay, question C. Fiona is considering these three properties, a 2-bedroom house, a 1-bedroom apartment and a 3-bedroom farmhouse. It also gives us the annual council tax payment here for each band. So it tells us the band there, band F for this one, so I'd have to identify that one, band E for this one, which would be this one. And this one says included everything, so I don't need to look for the band. And I presume this is a best buy question. It says, which property is the cheapest option? Use working to justify your answer. Well, it means I need to work out the price for each property then. So let's start off with the 2-bedroom house, 2-bed house. It says total monthly cost is £730, it includes everything. So no sum to do, that's £730. Let's look at the 1-bedroom apartment. Let's just call it the 1 bed. So that one is weekly rent of £132, council tax band F, and weekly electricity of 12. So first of all, for the weekly, I've got 132 plus 12. That's 144 per week. Now I want to compare like for like. So I'm going to get everything back to monthly or everything to annual. It's up to you. I'm actually going to get everything to annual because it'll be easier. So I'm just going to times that by 12 to find the annual. That one's 8,760 per year. This one is 144 per week, so times 52. That's 7,488. But I need to add something to this. The property is a band F. Band F is here, 216,864. So this is why I'm doing it in annual, because it means I don't have to do any division at the end. That's the annual council tax. So plus 216,864. And that is 9656.64. And that's per year. So that's me now done that one. So I now do the 3-bedroom. So it says monthly rent 390, monthly electric 76. So I do 390 plus 76. Using a calculator if I want, that is 466. That's per month, so I times that by 12. That's 5592, and then I need to add on the council tax band, which is E 183492. And finally we get 7426.92 for that one. So which one's the cheapest? Well, we've got 8760, then we've got 9656, and then we've got 7426.92. So the 3-bedroom farmhouse is the cheapest. 3-bed farmhouse is the cheapest. And we're done there. SQA National 5 Application Maths for 18, Paper 2, Question 11. A new hotel has been planned in Benidorm. The pool will have a walkway around 3 sides and it's 1.5 metres wide as shown in the diagram. We have to find the area of the walkway. So the walkway is the white bit, so this is just area of a rectangle, but I need whole area. If I do the whole area, and then I can just take away the pool, and that will leave me with the walkway. So let's do the whole area first. So our total length is from here to here. So I know it's 16 plus the 1.5. So that's 17.5 times the total height. Well, the total height goes 8, then 2 extra 1.5. So that's 8, 9, 10, 11. And use a calculator if you need to work out those lengths. So that gives me my total area, which is 192.5 metres squared. So then I'll just do the area of the pool. So that's just 16 along by 8, it says in the question. That gives me 128. So the area of the walkway is 192.5 minus 128, which is 64.5 metres squared. And we're done for part A. Part B, the walkway will be covered in tiles. 16 tiles cover 1 square metre. Tiles are sold in boxes of 50, each box costs €71.95. Calculate the cost of the tiles for the walkway. Well, let's check our answer. We need 64.5 square metres. It says 16 tiles cover 1 square metre. So I need to times by 16 because I've got 64.5 square metres. So let's times by 16 to start with to see how many tiles we need. That gives me 1,032 tiles. Next bit says tiles are sold in boxes of 50. So if I divide by 50, that'll tell me how many boxes I need. So for the boxes, I need 1032 divided by 50. Well, that's 20.64. Well, you can't buy 0.64 of a box, so that equals 21 boxes. So I need to buy an extra one and just have some extra tiles. It says each box costs $71.95, so it's 21 times $71.95 to get a final answer of 1510.95. 1510.95, and this is euros, it says. So 11 continues. The swimming pool is a prism with dimensions shown. Calculate the volume of the pool in litres. So if I want to know the volume of the pool, there's 2 ways I could do this. I could split it up into 2 shapes in volume and calculate the volume separately, but I think it's easy to just do it by area. So if I draw a line from here all the way along to here, I'll have a rectangle, and then I'll have a little triangle. So let me draw that out for you. I've got the rectangle first. Dimensions of that are 0.5 on this side, and the whole length is 16. And then I've got this triangle. Now you need to be careful with this bit. It is a right angle triangle. Its height is 2, but is it? Because that's an immediate thing you would think to do, because you look at it and go, oh, I see 2, so I write 2. But look, I've cut it here. So there's this little bit that I need to take off, 0.5. So watch out for that. I actually need to do 2 minus 0.5, which is 1.5. Similarly, going along the way, I'm not going all the way along. I'm stopping here, which is 4 short. So it's 16 minus 4, which is 12. And now I can do the area of both bits. And once I do that, I'll know the area of the whole front bit here. And to get the volume of a prism, you just times by the depth. So let's do our area. 16 times 0.5 plus a half of 12 times 1.5, because the area of a triangle is half the base times the height. So 16 times 0.5 is 8, plus a half, which is 0.5, times 12 times, and it was 1.5 height, not 2, which is 9. 8 plus 9 is 17 square metres. Then we know our depth is going in this way, which is the same as this one, so it's 8. So our volume is 17 by 8, which is 136 metres cubed. But that's not litres. So there's a few conversions you need to know for National 5 apps. You need to know that 1 centimetre cubed is 1 millilitre. And it's worth knowing, but you can work this out yourself, that 1 metre cubed is 1,000 litres. Now, how could you get there yourself, you're wondering? Well, 1 centimetre cubed is 1 millilitre. So that means that 100 centimetre cubed equals 100 millilitres. So what about 1 metre cubed? Well, that is 100 times 100 times 100, because it's 100 by 100 by 100 centimetres. So that would give you 100 times 100 times 100 millilitres, and then just divide by 1,000 to get in litres. Although it's just much quicker and easier, if you ask me, to remember that 1 metre cubed is 1,000 litres, because it comes up more often than not. So I'm just going to use that. 136 times 1,000, 136,000 litres. And we're done there.